So for this section, we're covering division of polynomials or rational functions. The first one we're going to cover is long division. So before we actually work this problem, let's review basic long division that you learned back in elementary sometime. But just to remind you, because the process of long division of polynomials is very similar. So let's just do a quick example. If you were to take 2 and divide into 171, right, the way we do long division is we take 2 and we see how many times does it go into 17. That goes 8 times. Once you put the 8 up there, remember you take 8 and you multiply by 2 right there and you get 16. Then you subtract and you get 1. That's your remainder. We're not through, so we can bring the second one down. We start over again. 2 goes into 11 5 times. 5 times 2 is 10. We subtract and we get 1. Okay, so the 1 is our remainder, right? But one of the ways that you can write it is the 85 we call the quotient, and if we have a remainder, we can bring that remainder up here and say 85 and 1 over 2. The 2 is what we divided by. So long division would be 85 and 1/2. Once again, this is just a reminder because what we're about to do with polynomial division is very similar. So now let's look at the problem. We're dividing x squared plus 5 into this larger polynomial. If you notice, the divisor is x squared plus 5. That is the same as x squared plus 0x plus 5. I chose this example for this reason. Sometimes you may skip one of the exponential terms. Like in this case, we skipped x to the first, but you must put a 0 in that place. Otherwise, it will mess up when you're trying to work out the problem. So it's dividing into x to the 4th. Notice that x cubed is missing, so we need to have 0x cubed plus 7x squared plus 4x plus 33. It looks really daunting, but let's start working it out. So to start the problem, all you're going to do is look at the first term of both of these polynomials. You're going to ask yourself, what does x squared go into x to the 4th? I ask myself, what do I need to multiply x squared by to get x to the 4th? So I multiply it by x squared. I need x to the 4th, so I need 2 more x's. Once you do this, you'll multiply x squared by each term of the divisor. So we have x squared times x squared is x to the 4th. Okay, this is what we want. We want them to be the same because our goal is to subtract it out to 0. So we have x squared times 0 gives you 0x cubed. And x squared times 5 is 5x squared. Okay, so now it's the time where we subtract to get the remainder. Now you could subtract the whole thing like this. Okay, but I usually don't like to write it that way. Basically, your negative, you need to divide through each term. So what I do is I change each individual term, change the sign, and then you can just add it. That's the same thing as subtraction. So we have x to the 4th minus x to the 4th is 0. 0 minus or plus 0x cubed is 0. And then we have 7 plus negative 5, which is the same as 7 minus 5. And then the x squared just comes down along with it. So this is why it's important to have your x to the 4th need to match up, the cubes and the squareds, so you can subtract. So this also happens to have 2 terms that multiply out to give you 0, or I'm sorry, subtract out to give you 0. The second one, notice we have the 2 zeros. That doesn't always happen. I just chose an example that it does, but you very well could have gotten a number right here. That's perfectly fine, but our goal is the first ones need to subtract out to give you 0. Okay, so let's keep going. So we have 2x squared. Let's bring the 4x down. Okay, and we'll start over from there. So once again, we're starting over. We have x squared, and we have 2x squared. We're going to do the same thing. We're going to see, what do I need to multiply x squared by to get 2x squared? If you notice, we have the x squared. We just need a 2. That's plus 2. And let's multiply it out. We have 2 times x squared is 2x squared, which is what we want. 2 times 0 is 0x. And we have 2 times 5 is plus 10. So notice that we have this plus 10, which means In this case, we could have brought the 33 down as well. Okay, we're almost done. We need to subtract this. And like I said before, you can subtract each individual term by changing the sign, and then you can add. So 2x squared minus 2x squared is 0. 4x minus 0 is 4x. And 33 minus 10, or plus negative 10, is 23. Okay, we're done because this is our remainder, right? And that is smaller than what we divided by, right here. So our answer, we're going to bring our remainder up top, right? And you just add it. 4x plus 23. You put it over what you divided by. Okay, let me write it neatly down here. So x squared plus 2, this is called our quotient. And then Pearson would like us to write our remainder as the remainder over the divisor, which was x squared plus 5. This is our answer. Okay, now let's move on to our other form of division called synthetic division. I really like this one. It can't be used for every kind of problem. It can only be used when you're dividing by something really small like x plus 3 or x minus 3. You can't use it when you have like an x squared you're dividing by. But it's great because what you do is you take the variables out of the problem and just use the coefficients, work everything, and then you put the x's back into the answer. Okay, let's give it a try. So for synthetic division, we're just going to use the coefficients. Okay, so we're dividing x plus 3 into x cubed plus x squared plus 5x minus 8. So what we're going to do is we're going to take the coefficients. So we have 1 for x cubed, another 1 for x squared, plus 5 and minus 8. So those are the coefficients of the larger polynomial. And then we're dividing by x plus 3. So what you're going to do is you're going to use the opposite. So if your divisor is x plus 3, you set that equal to 0 and solve, you get x equals negative 3. This is what you use as your divisor. Okay, so let's get started. To start it, you're going to bring the first number down. You always do that. And what you're going to do is you're going to multiply and add all the way down the table. So we're going to take 1 and we're going to multiply it by negative 3. You get negative 3, you put it in the next column, and then you add the 2. So negative 3 plus 1, right, you add that column, you get negative 2. And then you start over again. Negative 2, you always multiply by negative 3. So negative 2 and negative 3, multiply together, you get positive 6. Add the 2, you get 5 plus 6 is 11. Do it again. 11 times negative 3 gives you negative 33. Right, isn't that right? Negative 3 times 11. Add the 2 and you get, what is that, 41? All right, and you're done because you can't go any further. The last number is always your remainder, okay? And then these first 3 terms right here, those make up your quotient. Those are the coefficients. So all you have to do is put the x's back into it. So we start with 1. And it's going to be x to the 1 less power than what you originally had. So our original power was x cubed, so we're going to do x squared. And then everything works down from there. So you'd have minus 2x to the first plus 11. Okay, so that's your quotient right there, quotient. You don't have to put the 1, of course, if you don't want to. They usually don't do that, so I'll erase it. And that's the quotient. And then you have your remainder. So the remainder, of course, remember we're going to write it as minus 41 over what we divided by, and we divided by x plus 3. Okay, so you could write it this way. Now I do realize you could also say, since it's minus, you could write it as plus a negative, and that's the same thing, and you're good. Now before we move on to the next problem, I want to show you a situation that could come up with a different problem. Let's just give you a different example. We won't work it the whole way. I just want to show you how to set it up. Let's say we were dividing by, we'll just make up something, 2x cubed plus 3x minus 1, and we'll divide by x minus 7. Okay, just to set it up, if you notice, we have 2x cubed, but there's no x squared term. You need to have a 0 in that place. You have to have a place for each exponent place. So you would set that up by saying we have a 2 for x cubed, nothing, a 0 for x squared, a 3, and a negative 1. And then we're dividing by x minus 7, so remember we use the opposite, so we'll use 7. Okay, that sets it up. I just wanted to show you that to make sure you're aware of how to set it up, because you won't know that you're working it incorrectly if you fail to put the 0. You'll just get it wrong. So this is one of the problems from our homework. I wanted to work this for you because some people have had trouble with it. Okay, we talk about zeros. So if you remember from our last section that we covered where we had to find zeros, I just want to remind you of this. If you had a function and you were able to get it in factored form, which would look something, I'm just going to make up something. This is not the same function as what I've given you in the problem, but if you had something like x plus 2, x minus, x plus 2, x plus 1, x minus 7, we got it factored, and I asked you to find the zeros. Remember, you just take each one and you set it equal to 0 and solve. And you get, let's see, x equals negative 2. This one would have given you negative 1 and 7. So this function had 3 zeros, right? Okay, well, there's a connection between zeros. Let's look at negative 2. If negative 2 is a 0, then x plus 2 is a factor. So they're related. So like I said, if x plus 1 is a factor, right, then x equals negative 1 is a 0. They go together, okay? So once again, x equals 7. If that is a 0, then you know that x minus 7 is a factor. That's a factor of f of x. Okay, and remember what a factor means. It's just if you took a number and you were able to divide it evenly into a function, that's a factor. This was just a little summary before we dive into this problem. Okay, for this problem, find the remaining zeros of f of x, then rewrite it in completely factored form. Okay, they give us that c equals negative 4 is a 0. That's very important because that's going to help us factor. Our goal is to find the zeros. We have to have f of x in factored form. But f of x is x cubed, so we can't just look at this and factor it very easily. But the fact that they give us negative 4 is a 0, that helps us because we know that if negative 4 is a 0, then it divides evenly. Let's see, if x minus 4 is a 0, that means x plus 4 is a factor, right? It means it divides evenly into the function, so the way we'll work it is we're going to divide it. We're going to use synthetic division, so we're going to divide into our main function, which would be 1, 8, 19, and 12. Okay, and I'm dividing by x plus 4. But look, if you know that negative 4 is a 0, that's what you use when you're doing synthetic division. So we'll use negative 4. Since it's a 0, we better get 0 for the remainder because it's supposed to divide evenly. So let's synthetically divide. We start with bringing 1 down. Remember, multiply and add. 8 minus 4, or 8 plus negative 4 is 4. Multiply again. 4 times negative 4 is negative 16. We add and we get 3. And lastly, 3 times negative 4 is negative 12. We add, we get 0. Okay, which is what we wanted. Okay, that leaves us. Here's our quotient. It went in evenly, so that would be 1x squared plus 4x plus 3. Okay, so we basically just factored it. So to find the remaining zeros, we just need to have this factored. So let's think about it. Let me write this. Remember, from the beginning, when negative 4 is a 0, we know that x plus 4 is a factor. And this is what I just did. I divided x plus 4 into the function, and I got x squared plus 4x plus 3. So to find the remaining zeros, let's just factor that. And we know how to do this just by looking at it. So that would be x plus 3, x plus 1, and it factors. All right. So this is where some people make mistakes on the homework, and it's just very tedious and frustrating. But they asked you for remaining zeros, so you can't include the original 0 in the answer. So once we have it factored, we know that if we set that equal to 0, we get -3, and here we get -1. Okay, remember this was already a 0, that was given, so these are the zeros, right? But if you list all 3 of these in your answer, it's gonna get counted off wrong because they asked for the remaining. So when you type it into Pearson, only list the remaining zeros, -3 and 1. Okay, that's the first part. And then the second part, it says right up here, write in completely factored form. All they want you to do is write the whole thing factored, which we kind of have right here. So you would type in, x plus 4 times x plus 3. And lastly, x plus 1. This is f of x in factored form. Okay, this one is very similar to the previous problem. So let's work it. I just wanted to, the only thing that's different was talking about a 0 of multiplicity 2. So let's work this one. Okay, we know that c equals -4 is a 0. Okay, remember that tells us that it's a factor and it divides evenly into the function. So let's do synthetic division. Remember, we can use our 0 to divide in our function. 0, 10, 32, and 32. All right, it should go evenly because it's a 0. So hopefully my remainder will be 0. So let's start it. Bring the 1 down, multiply, and add. 10 plus -4 is 6. Let's multiply. 6 times -4 is -24. We add that. 32 plus -24 is 8. 8 times -4 is -32. We add those, we get 0. All right, so it did go evenly. This gives us what our quotient is, which is 1x squared plus 6x plus 8. All right, so let's think about it. We just factored it. Remember, we used c equals -4 is a 0, which remember what I just talked about. If -4 is a 0, then x plus 4 is a factor. Okay, this is our function. Okay, now we have this one small remaining trinomial to factor. That would be x, 4 times 2. So it factors. All right. Okay, so we just got it factored. Okay, so remember, solving for zeros, it happens to be, remember, we know this 0 is -4. Well, look, this is the same factor. So we get -4 again. And this 0 would be -2. Okay, so these are the zeros. All right, the reason I wanted to work this one is to talk about the multiplicity of 2. Remember, multiplicity of 2 simply means that the factor x plus 4 showed up twice. Okay, x plus 4, x plus 4. Therefore, we got the remaining 0. We got 2 zeros of -4. So when you're listing the remaining zeros, the only one you would list would be -2 because -4 was already given to you. The only one remaining is -2. Once again, that's really tedious. If you did this on a test and you listed all of the zeros, I certainly would not count off. But Pearson counts off for it. And then finally, write in completely factored form. It's right there. Okay, you can write it all out like that, or you could write it x plus 4. Since there's 2 of those, you could write it squared. Let's see, make sure. You could do it that way. Or, once again, you're welcome to write it out like that. Either way should be fine. And that would be your answer.